Okay, so in the last video we took a look at ODEs and we found that the general solution to a first order ODE in this form can be given by this, k is equal to plus or minus e to the z. In this video we're going to take a look at how to solve some slightly more complicated problems by using integrating factors. So let's say we're given the equation dy by dt minus 2y equals 4 minus t. We know already that we can't directly apply this general formula, so we need to use the method of integrating factors. Okay, so in this example I'm going to use the Greek letter mu to refer to our integrating factor. So if we multiply both sides by mu of t, we get this equation here. Now, in order for this process to be a simplification and not a complication, we need to choose a mu of t so that the left-hand side is a derivative of known quantity. So what that means is we need to choose a mu of t, which, when we take the derivative of it, using the product rule, we can get this expression. So we're attempting to simplify this two parts into one part. So through the product rule, we know d by dt of our integrating factor times y is equal to our integrating factor times the derivative of y with respect to t plus the derivative of our integrating factor with respect to t times y. And if this doesn't make sense to you, I would encourage you to watch videos Euro 2.3 in the calculus playlist. And notice as well that this needs to be equal to the left hand side of this equation as well. Okay, so next we need to work out what our actual integrating factor is. So if you'll notice, for this to be true, we can effectively take a mu of t dy by dt from both sides and divide both sides by y. So it must be true so if this is true, then this must also be true. And now we can calculate our mu of t value. So if we divide both sides by mu of t and use our separation of variables technique, this gives us and this gives us this. And I've simply dropped the function notation here just for convenience. So then if we integrate both sides, we have that the natural log of the absolute value of mu is equal to minus 2t plus our constant c. And then when we solve this equation for mu of t, we get, finally, that our mu of t value is equal to, we'll call it capital C times e to the minus 2t, where capital C is defined as plus or minus e to the c value, which is similar to what we did in the previous video. Okay, so now let's reinsert our mu of t into this equation here. And when we do that, we end up with this. And as you might notice, the c values can all cancel out as well. And this part of the equation also came from the product rule, so we know that that is the same thing as d by dt of our mu of t times y. And now we're left with something that we can integrate directly. So if we use our separation of variables techniques, and by doing that we end up with this, where we can integrate this directly. So the left hand side of the equation would just become e to the minus 2ty, and then for this we can just use the reverse chain rule, so this will become e to the minus 2t divided by minus 2. And then this integral here, we can use integration by parts. And if you're unsure as to what that is, more information can be found in video 03.3 of the calculus playlist. And now that we've integrated both sides of our expression, we no longer need our integrating factor. So what we can do next is divide through by e to the minus 2t. And now to solve for our y of t, all we need to do is simplify this expression. So this part in square brackets here came from our integration by parts. So this can simplify down to we had minus 2 minus a quarter, so we have minus 2 plus a quarter, so we have minus 7 quarters, plus a half t, because minus and minus is a plus, and finally plus c e to the positive 2t, because 1 over e to the negative 2t is the same thing as e to the positive 2t. And that's it. So hopefully this video has helped you understand the integration factors a little bit more. In the next video we're going to take a look at the case where the right hand side of this equation is a variable instead of a constant. And as always, if you have any questions or comments, please feel free to pop them in the comments box below. And I'll see you in the next video.